In this video, we'll be looking at differentiation of a product, where we'll be emphasizing on product rule. And if you're not subscribed to this channel, do subscribe and share this video to your colleagues as well. Now let's start. Differentiation by product rule. When we have a function such as y, which is equal to x squared multiplied by 2x plus 1, we can easily differentiate by expanding the function, of which when we expand, we have y is equal to x squared by 2x gives us 2x cubed, and then x squared by 1 gives us x squared. So after expanding, we can easily differentiate, which means dy on dx is equal to 6x squared plus 2x. So with functions like this, when we expand, we can easily differentiate. In most cases, we can be confronted with functions that we cannot easily expand, and so the idea of product rule comes in. So that is all about product rule. It helps us to find the product of two functions as we differentiate along. So now let's look at the product rule itself and what it entails. So when we talk of product rule, this is what it means. If we have a function y which is equal to uv, where u is a function of x and v is a function of x, then the derivative of y with respect to x, that is dy dx, is equal to v du dx plus u dv dx. And so when we talk about product rule, then we'll be working along with this formula. So this is what we are going to use whenever we have a question and we want to apply the product rule. Let's bear in mind that the formula is very important, and it is read as dy dx is equal to v du dx plus u dv dx. Now let's look at practical instances where we can apply the product rule. So example 1, it says that if y is equal to 2x minus 1 multiplied by the function 3x plus 2, find dy dx. So here we have our solution here. In the question, it said that y is equal to 2x minus 1 multiplied by 3x plus 2. So since we are going to apply the product rule, we first have to write the product rule there, and then we look at the necessary parameters we are going to require in solving it. So the product rule says that dy on dx is equal to v du dx plus u dv dx. So this is what we are going to use in solving for the question above. So in this question, it means we have to identify our u and v and find their derivative as well. So from the question, the first function here, 2x minus 1, becomes our u, which means u is equal to 2x minus 1. And the next function, 3x plus 2, becomes our v, which implies v is equal to 3x plus 2. So once we are able to identify it that way, we find their derivative. So this is what we are talking about. Then we can see that u is equal to the first function here, that is 2x minus 1. And the next function, v, will now be equal to 3x plus 2. So once we are done, we find their derivative with respect to x. So here we have du on dx to be equal to, so we differentiate 2x minus 1 with respect to x, we have 2. And then we move to the function represented by v, which means dv on dx will be equal to, when we differentiate 3x plus 2 with respect to x, we have 3. So once we have our u and then du dx, v dv dx, we come back and substitute into the product rule formula. So we come back, and in here we have our dy on dx to be equal to, now we said that v here is equal to 3x plus 2. So we repeat that as such. So you have 3x plus 2 multiplied by du dx, and du dx, we said here that it is 2. So you multiply by 2, and then we add it to, now u we said is the same thing as 2x minus 1. So we write multiply by 2x minus 1, and we multiply by dv dx, and dv dx here we said is 3. So multiplied by 3. We continue with our solution by writing our dy on dx to be equal to, so it means 2 multiply everything here. So 2 by 3x gives us 6x, 2 by 2 gives us plus 4, and then we have plus 3 by 2x gives us 6x, and then 3 by negative 1 gives us minus 3. So we can simplify, and then here we have dy dx to be equal to, so you can see 6x plus 6x gives us 12x, and then 4 minus 3 gives us plus 1. So differential of the function above, that is y is equal to 2x minus 1 multiplied by 3x plus 2, is equal to 12x plus 1. Now, the good news here is that there is a short procedure to product rule, and let's see how best we can work it out for this question. So let me write here a short procedure. Short procedure. Now we have to remind ourselves that a short procedure is a short procedure, and we mostly apply the short procedures in section A's. But when we are working with section B, questions involving product rule in section B, it is advisable for us to use the formula and apply it. So I'm talking about the first solution we had, but we can apply the short procedure in section A, or instances where we need instant solution for product rule in differentiation. So this is how the short procedure for product rule works here. In the question, we're given y is equal to 2x minus 1 multiplied by 3x plus 2. Now, since we want to find dy dx of this function, then we can write it as dy on ds, that is, with differentiating y with respect to x, is equal to, so the short procedure says that first maintain the first function, and the first function here is 2x minus 1, so we maintain it. So maintaining it means that we write the same thing here. Now we maintain it and differentiate the next function. So when we differentiate the next function, that is 3x plus 2, we have 3. So we multiply by the differential of the second function. Now we are done. We are not done fully, but we are done partially. So we add it to, remember that the first instance we maintain 2x minus 1. So in the second instance here, we are going to maintain 3x plus 2. So we maintain 3x plus 2. The next idea here is that we differentiate the first function. So we differentiate the first function here, we have 2. So you multiply by 2. So in this case, we are done. What is left here is by we expanding. So that is dy on dx here is equal to, so 3 multiplied by 2x gives us 6x. 3 by negative 1 gives us negative 1. So that is negative 3 plus 2 by 3x gives us 6x. 2 by 2 gives us 4. So we can simplify by saying dy dx here is equal to 6x plus 6x gives us 12x, and then minus 3 plus 4 gives us plus 1. And at the end, you could see that we are getting the same answer as we had for the first one when we applied the formula. So there's a short procedure and the normal procedure. So let's know the instance where we can apply them in that regard. So we tried the last question for this video, and let's stay tuned. So we have with me example 2, and example 2 says that find dy dx if y is equal to 2x squared minus 1 multiplied by x cubed plus 3. So solution here, we can see that the function here was given as 2x squared minus 1 multiplied by x cubed plus 3. And these are two functions multiplying. So we can apply the product rule. So the product rule says that dy on dx is equal to v du on dx plus u dv on dx. So it means that we have to identify our u and x from the function, our u and v from the function, and then do the necessary substitution. So it implies that from the function 2x squared minus 1 is the first function, and that will be u. So it means u is equal to 2x squared minus 1, and then our v becomes the next, that is v is equal to x cubed plus 3. In this case, we differentiate them with respect to x. So here we have du, it should be du on dx, differentiate 2x squared with respect to x, that gives us 4x, and then we have dv on dx, differentiate x cubed with respect to x, that gives us 3x squared. So now that we have u and then v together with their derivative, we come and substitute into the formula. So here we have dy on dx to be equal to, now it says v, and v is s cubed plus 3, so we write s cubed plus 3 here, multiplied by du dx, and du dx we said is 4x, so we come and write by 4x, and then we add it to u. We said u here is 2x squared minus 1, so into bracket 2x squared minus 1, multiplied by dv dx, and dv dx we said is 3x squared, so we have our 3x squared here. What is left here is for us to expand. So when we expand this, then we can see that 4x multiplies x cubed gives us 4x exponent 4 plus 3 multiplied by 4x gives us 12x. We add it to, so 3x squared multiplies 2x squared gives us 6x exponent 4 minus negative 1 multiplies 3x squared gives us 3x squared. So we continue by further simplification, and we have our dy dx to be equal to, so 4x exponent 4 plus 6x exponent 4 gives us 10x exponent 4, and then we have our minus 3x squared plus 12x, and this becomes our solution for this question. So that is how we can apply the product rule. We can equally apply the short procedure, and then we look at how best we can also solve along with it. So let's continue with the short procedure here. Short procedure. Now it doesn't mean that when you use the product rule and you get the answer, you have to come and use the short procedure and then solve it again. No, just stick to one. But in this case, when we have the question in a theory form, you have to go by the normal process just like we did here. But if it's objectives, then we can also apply the short procedure in getting it. In other ways, any of them give you the same answer. So in the question, we're given y to be equal to 2x squared minus 1 multiplied by x cubed plus 3. So the short procedure says that if you are differentiating y with respect to x, then you have the y on dx, which is equal to, so first we maintain the first function here, that is 2x squared minus 1 maintained. So we have 2x squared minus 1 maintained, and then the next is for us to differentiate the second function. So in differentiate x cubed plus 3, we have 3x squared. Now when we are done, we add it to the next. So you remember that in the first instance we maintained the first function. So in the second instance we are going to maintain the second function, that is x cubed plus 3 maintained, and then we differentiate the first function. So when we differentiate this, that is 2x squared minus 1, differential gives us 4x, so we multiply by that respectively. It means that our dy dx here, when simplified, gives us, so 2x squared by 3x squared gives us 6x exponent 4, and then minus 1 multiplies 3x squared gives us minus 3x squared. So plus of, now 4x multiplies x cubed gives us 4x exponent 4, and then 3 multiplied by 4x gives us 12x, of which we can simplify and have our dy dx as this form. So 6x exponent 4 plus 4x exponent 4 gives us 10x exponent 4, and then we maintain that of 3x squared, and then also add that of 12x. And this is how we can apply the short procedure in solving for questions involving the product rule. Yes, so I have a special gift for you, and stay tuned with me and let me reveal that to you. Yes, and this become my special gift. It says that solve and share your answer in the comment section. So I have a special gift for you if you're able to solve it and share your answer in the comment section. And the question says that if y is equal to x squared minus 3x plus 2 multiplied by x squared minus 2, find dy dx. So if you're ready for this special gift, then try your hands on this and share your answer in the comment section, and I'll hit you up for your special gifts. So thanks for watching. We end today's video here. Kindly like, comment, subscribe, and share. Remember that this is Bakumat. We are thinking beyond infinity.